Oh, should I do something?
Hello, everyone, and welcome to Tech Leaders Hub, episode number 21. My guest today is Daniel Gebler, CTO at Picnic. Daniel, how are you doing today?
Very, very good. Thanks for having me. Looking forward to it.
Yeah, I'm really looking forward to it too. And thank you, all watchers and listeners, watching this from the very first minute. Whether you're joining live or whether you're watching the recording, thank you so much for spending time with Tech Leaders Hub and spending some time to upgrade your tech knowledge, your leadership knowledge, and to get inspired. We hope you'll enjoy the show today. First of all, dear watchers and listeners, if you can see us and if you can hear us, please leave us a comment so that we know everything is working. This is getting recorded. So we want to make sure that you can see us and hear us all correctly. Meanwhile, Daniel, the topic of our session, which I'm really excited about, is this. We had this preliminary conversation a little while ago. I am so sorry. I think I'm gonna just switch my video just before we proceed because I don't want to look like that. Okay, never mind. The topic is this magic formula of growing in all directions at once. And I'm thinking, for the conversation that we have, for the knowledge that you have to share today, who do you hope is tuning in? Who do you think will benefit the most from what we have to talk about today?
So I hope that we have pretty diverse listenership. People that have some form of affinity to tech, which means developers, but also product owners, business people that build and deploy and operate tech products. What I'm most excited about is that we will talk a bit about what is the potential of technology when we are building it in a scalable and well-architected way. And the reason why I'm so excited about this is that startup and scale-up business building is all about building technology now that can either pivot to another business model tomorrow, or be scaled to the size that you need tomorrow.
Okay. Yeah, I'm very excited to dig into all of that. So if you're interested in any of what was just said, stay with us and we'll explore more of that during the session. Andrzej here in the comments on LinkedIn is saying that it's perfect. I assume the audio and video, but maybe like also his day and everything else related to that. So thanks, Andrzej, for mentioning that. Anybody else, leave us a comment. Nobody from YouTube, maybe somebody was watching on YouTube. We're also on Twitter. Looking forward to seeing your comments. And remember, throughout the whole session, ask Daniel your questions. We've got him here for an hour to share his knowledge. Meanwhile, Daniel, what I like to do on Tech Leaders Hub here as a kind of tradition is before we dive into a little bit of your background, talking about Picnic so that people know what kind of experience this is based on, I wanted to ask you the traditional Tech Leaders Hub question. So I hope you're ready for it because here it comes. Daniel, what is your number one tip for tech leaders?
That is pretty cool that you start with this, because that is a common question that people ask at the end after a lot of kind of stuff has happened. I think the most important lesson that we learned over the last years is that it's not so much about the technology choice that you make, but more the architecture that you use when building something. That's number one. Maybe one bonus one is if you build something, look into the cost of change and not on the cost of building. So when we're building software, we all try to do a little bit of planning. We think about an agile and a scrum process to build it in a most efficient way to easily launch it to our customers. But actually, not many of us are looking into how difficult is it to change what you have built. If you truly think about data-driven, experiment-driven software development, then what you know is that the software or the product that you're building now needs to be changed 10 times, 100 times, 1,000 times. So you should optimize that these 1,000 changes that you do afterwards are as painless as possible, and not that the first version is as quickly as possible built.
It's very interesting. So you're talking about making these changes painless. What are kind of the steps towards that? What should tech leaders kind of pay attention to, or tell their teams to pay attention to make these changes, not so costly?
I think there are two things. Number one is you should all apply an evolutionary architecture, which in very simple terms, there's an entire theory behind it. But the business value of it is that it makes the cost of change of the architecture, not only the implementation technology, as optimizes for low cost of change and not low cost of building. That's number one. Number two, doesn't matter if you're a product owner, if you're a business operator, if you're an engineer, or if you're QA, you need to understand the architecture. You don't need to understand all features, you don't need to understand all use cases, but you need to understand the architecture that you have built, because that is really driving the opportunity of tomorrow.
It's interesting. So just to follow up on this a little bit more, because I'd like to kind of unpack some of the concepts that we're going to be using just upfront, again, to kind of give the maximum context to the people watching and listening. When you say architecture, what do you mean by that? Is it how the the databases relate to the back end, to the front end? What else is there that is hidden under this this word here?
So with architecture exists on different abstraction levels. So you have high level logical architecture, implementation architecture, you have test architectures, etc., etc. So this is altogether one aspect of it. The second aspect is, beside the technical or the software architecture, you have also product architecture. What is very important is that product owners and business operators think carefully about the product architecture that can communicate with engineers in the language and the kind of the interface of an architecture. So it is not so much that the kind of a business owner tells you, well, I want to have this feature realized, customers are asking me more for this, but it's about that the business owner thinks a bit about conceptually how does a new feature request or a new business request fits in the overall product vision and product architecture. And that makes it much easier and a less painful dialogue between engineering, tech, and business. And that makes also this, everybody talks about tech and business needs to come together. Tech is basically the opposite of business. If you have this kind of product architecture well-defined and communicated, then you automatically have a language that glues both sides together.
All right. So is this related to, and this might be a miss, obviously. Is this related to, I don't know, I'm talking with one of our users, let's say, I'm responsible for product development, or maybe I'm getting some feedback on the, I don't know, customer support side. Again, correct me if I'm wrong at any point. And they're requesting a new feature. Is this about just being aware of, okay, I'm hearing this feature is being requested, but I'm also aware of all the other features that are already in the application, and this somehow there's going to be either a clash or some confusion if we add this new feature. Am I on the right track here?
Certainly. So I think the interesting thing is what product owners have traditionally done, and tech leaders, is say analyze a single feature or a single kind of implementation and see a bit what is the most efficient implementation, how do you make it scalable, resilient, how do you test it, all this kind of stuff. And we are really good altogether doing that. What we are as an industry not good enough yet is putting a new feature or a new implementation in the context of everything what you have built. And when you're thinking a bit about an aging system or a kind of a system that is much bigger, then a new feature is always in the context of everything what you have there. So maybe you have already built something which is similar to this. Maybe a feature is more a generalization of an existing feature, etc. At some point, if your system is large enough, you will no longer be able to spot this if you're not talking, well, let's say if tech is not talking with business in terms of the product architecture.
Okay. Well, yeah, so that explains a lot. I think it's a very valuable kind of expanded number one tip. I want to dive more into this in just a few minutes. But before we kind of get more into that, I wanted the watchers and listeners to get to know you a little bit better, So could you, spend a moment talking about, your path here, where you are right now, talk about Picnic, about yourself, just so people have this little bit of context and so that we know what kind of who we're talking with at what kind of company. If you could give us a little bit more.
So Picnic is an online supermarket, food and logistic disruptor that we started in 2015. So by now 7 years ago here in Amsterdam. I myself came to this wonderful city to do my PhD in computer science. Love the city, love the country estate. I did at some point also an MBA, but this is just education. So that is not, this is only, let's say, the very early things that you do at some point. What is more important is that I have first worked a bit in B2B, where we built a retail recommendation platform, which is essentially building this users who bought that, bought also that, or users may like that. So the most important part of an e-commerce site. And what we learned here is basically two things. Number one is we learned to separate what is important and what is less important in retail tech. And number two is that everything what is non-food, so electronics, books, fashion, etc., is already pretty mature if you look to the entire e-retail world. If you look to food, that is something, and I'm now talking from a 2015 perspective, is already super immature. There's so much more to do. It is the same size of market. So non-food is the same size as food, as a kind of a retail market. But actually, food is only a market that is 1-3% big if you look to the entire retail size, while non-food, so electronics, books, fashion, is already 20, 30, 40, 50%. So we thought that there's a nice business opportunity, but also on the tech side, because it's so immature, and immature means it's so traditional, and there's so much opportunity to do with modern blockchain and crypto and whatever kind of technologies make it more advanced, that this is something we immediately saw an opportunity to go into and to really make a change with technology and create a direct and lasting customer value.
Okay, so what I'm hearing is you were looking at buying food versus buying non-food products online, and you saw that the experience of buying food is just way behind everything that's non-food, and you thought to change that. Would that be accurate to say?
Exactly. And the way to put this maybe a bit in numbers, if there's only 2% of customers that are buying food online versus 98% offline, then you have a very different dialogue than if you have half of customers buying electronics online, half offline. If you're an electronics retailer, then in order to win online, somebody else needs to lose in the online game. If you are a food retailer online, nobody else in the online game needs to lose. You just need to convince somebody from the remaining 98% that are still doing food shopping offline to come online. So this is a much more attractive way of working and way of developing and innovating.
Right. So the competition is completely different because instead of looking at the other online stores, you're competing against getting up from your couch and going to the store.
Exactly. So in essence, our biggest competition is not even classical physical retail, but it's more the habit of people. And what I mean by this is, for instance, food shopping, you do much more often. So typically you go 2, 3, 4 times per week to a physical supermarket. And what happens if you go for 10, 15, 20 years, a few times per week to a physical supermarket, tomorrow you will go again, because this is simply a learned habit. So therefore, for us, the real thing, what we need to break, or what we need to, what we compete against, is the habit of people to go to a physical supermarket. And there, technology plays then also a role, because technology can give a better price point, can give much more attractive offerings, and can also simplify the process of not only shopping for food, but also getting food delivered.
Yeah, I mean, personally, to me, that sounds just exciting on a personal level because I really dislike going to the physical store. I would rather have everything come to me. So I really want to hear more about that. Look, let me just do a slight detour here because we have a question coming in from Cesare from the audience, and I really like to kind of emphasize the questions. You have questions, ask them, we will address them. So before we go into how Picnic, I assume, started to address that, Cesare is interested in this evolutionary architectures part. So let me read this out because some people are only going to get the audio on the podcast, and then I'll love to hear your answer. Cesare is asking, regarding theory, would you recommend, and it's the title of a book, building evolutionary architectures support constant change? Does that ring a bell?
No, the book. Have read probably most of the books that are out there regarding evolutionary architectures. There's all kind of research papers. The interesting thing is, most of the books, none of the books is really good. So, but on the other hand, maybe I should say it better. Most of the books are actually pretty good. So you will not make a big mistake. By the way, this book is also a pretty good one to read. What you need to do is that evolutionary architectures as a theoretical concept, as an academic concept, is a pretty abstract thing. So you need to find your own implementation on how to build a resilient or an anti-fragile implementation or with your architecture in your domain. So what it meant, for instance, for us is that we looked not only in the software architecture but also that we combined the software architecture with the physical architecture that we have in our warehouses, that we have with the vehicles, and combined it in a holistic architectural picture that captures both the physical world and also the digital world. If you look to classical UML type of architectural diagrams, it only models the software architecture and then a couple of actors. which is the classical way of looking into system design based on those kind of principles, with a perspective that models both the logical and the digital aspects and the physical aspects and the system actors. You get a much more holistic view on a system, and you can also decide what do you capture, for instance, from a resilience and scalability perspective in the physical architecture, maybe with a self-driving car, or maybe with a self-accelerating, self-braking a car, versus what you do in the digital planning software.
Wow. Okay. So mapping this architecture, both like digital and physical, is that something that you've done also at Picnic? Am I getting that right?
Yeah, we have certainly done this here. Probably not good, not yet good enough. So I'm looking into doing much more with it. But we are certainly have done major steps there. This entire many of us have heard about and maybe have worked with the notion of a digital twin, which is very closely related to this, where you build a digital model of your physical world. But actually, it can go also the other way around. You build maybe a physical twin of the digital world. And if you think this concept a little bit further, then you need to also think architecturally about what does it mean if physical and digital aspects are moving more and more together. And you see this, for instance, in cars like Tesla, where you have a also a holistic view on a physical and a digital architecture, where you have clearly a lot of kind of physical aspects are moving more to the digital space or the software space and are modeled over software. This is the main difference of the Tesla architecture versus a traditional Mercedes from 1980.
Right, because as I understand it, the Tesla cars, they're so kind of self-aware on the software level with these sensors that they've got. You know, they know what's happening with each physical part of the car as it's as it's functioning.
And if you model this in a physical way, a car has a driver, a car has other kind of physical a camera. So this kind of technology also existed certainly in cars of the 80s and 90s, etc. But Tesla has one of the first companies that is actually modeling the entire physical and digital space in one holistic picture. And then the decision, what do you digitize and how do you transition more of physical architecture to digital architecture, is a kind of a very new perspective to take.
Okay, wow, that's very interesting. Let's put a pin in that just for a second. I still want to kind of build for the watchers and listeners the kind of the context of Picnic in general. But thank you, Cesare, for the question. I love everything Daniel said as the answer. So thank you so much for stimulating the discussion. Okay, so backtracking just a little bit. We were talking about this untapped food e-commerce market that you were looking at. And now, well, that brings us very smoothly to Picnic, kind of the value proposition. How did you decide to change that? And how did you kind of go about it? And how did it scale? Tell me everything about that.
Yes. So the starting point where basically we looked into what is the reason that this food market is still so small and then as the online fraction, and they identified two things. Number one is nobody wants to wait, and number two, nobody wants to pay more than in the offline variant. So there is a kind of
that's true for me too.
That is kind of first principles very clear for everybody, but it has, if you think conceptually and structurally about it, it has clear implications. So if you don't want to wait, then you need to not only deliver faster, but you need to deliver in smaller time windows. And the interesting observation is it's even more important what is the kind of time window that you deliver. Typical delivery services give you a window of 2 hours, 4 hours, 6 hours. If you make out of a 6-hour window, maybe only a 15 or 20-minute window, then people are actually much more willing to order with you. That's number one.
The window is basically the promise of your groceries are going to arrive between 7 and 8 p.m. And you're saying if it's a longer time span, people are less willing to buy. But if they know it's coming within those 20 minutes, they can kind of plan their day around it.
Exactly. What is happening? So an example is a Dutch family typically eats dinner at 6 o'clock. Normal delivery companies told in the past that they will deliver between 4 p.m. and 8 p.m. Now you have an issue as a family. If it's 4 p.m., you can use it for dinner. 8 p.m., you can't. So that is simply not good enough. This is just not good enough. So in reverse, if you tell them, well, we will deliver between 5:30 and 5:50, then it's pretty clear if you want to make a dinner at 6 o'clock, you can use it. If we tell you upfront, we could deliver between 7 and 7:20, then you simply won't. You will use other food. And this kind of clarity in communication, which sounds very easy now, but was not that obvious in the beginning, helps customers to plan their day and actually gives them comfort to order online.
Okay, but how are you getting that done? How are you able to, because it's easy enough to say it's going to be delivered within those 20 minutes, but obviously logistically, it's a huge challenge. So how are you actually, addressing that?
So first of all, you need to identify that this is relevant for customer. So that's if you have done this, then just putting it out as a statement to a customer is the first step. But then living up to it, this is what you're bringing as a point. It's actually pretty hard.
Yeah.
It has two angles. Number one is making much more accurate plans than anybody else before. But this by itself is not good enough. And then make the plan happen. So making a more accurate planning is, there's a lot of AI and machine learning and deep learning that we use in order to make very accurate logistical planning. And that includes also traffic forecasting. That means not at home forecasting, all kind of stuff that you can do much more accurate if you have a larger customer base and a very tech-oriented way of running your logistics. The second one is that you actually reverse your operation, that you say at some point there's a plan out, and then operations means live up to the plan. And then you steer your plan and the way how you do logistics that you deliver on time to all your customers. And then there's an entire operational process that makes this happen. That may also mean that if somebody's late, that you have a second car that is delivering to customers, all kind of stuff to make it possible that every customer gets its delivery proposition fulfilled.
So that's the kind of challenge in the physical logistics of it. Can you tell me anything, because obviously techleadershub watchers and listeners are going to be curious about the technological challenge involved?
Yes, so I think the interesting topic on the logistics side is how do you plan this? And the real interesting thing, and maybe more on the algorithmic side, is you make a full day plan, which is a classical travelman salesman problem. It's actually an extension of travelman salesman, which is called VRTWP. So for those out there that have not heard, and this, by the way, nearly everybody, nobody has heard this before. This is vehicle route planning with time windows and capacity constraints. And time windows means you deliver between 5 and 6 or between 5 and 5:30. And capacity constraints means you have maybe 20 cars and each car can hold 5 orders. This is kind of an extension. So there's a polynomial algorithm that allows you to translate this VRTWP problem in a travelman salesman problem. As your readers will very likely know, I said TSP is an NP-hard problem, which means that if the problem is big enough, so you have large enough orders and deliveries that you need to plan, you can no longer accurately compute it. It would take just too long. So therefore, you need to apply heuristics. For the heuristics, and that is kind of what we have developed here, we have found a very smart way of basically slicing the problem in sub-problems that we can solve in quasi-exact notions. So basically, we distribute or we shape the entire country in sub-parts and sub-regions and another sub-regions, which becomes like a big puzzle. And then we can build the optimal route between those kind of big sub-puzzles. These are small areas, for instance, in cities. And then we have a quasi-optimal route between those kind of puzzle pieces that is driven by the deliveries, or that is the result of the deliveries of the last 4 weeks.
All right, so you're using historical data to inform that.
Historical data plus optimal calculation of a sub-region will deliver to a 95% accurate route or optimal route for today's operation.
My mind is blown by all
then you get to a very nice self-learning system, because you take today's operation as a feedback loop also into tomorrow's planning. So therefore, every additional day generates a little bit of more data that is put as input for the planning of the next day. So therefore, this is a system that becomes every day a little bit smarter, where just more operations, meaning just delivering for more days, makes the system better and better.
It sounds like really fulfilling the promise of machine learning, that it's thinking like a human, learning like a human, and doing a better and better job at whatever it's told to do.
At least we are aiming for it. It's not yet. It's certainly not Skynet, but we are certainly aiming for a very smart distribution system.
Yeah, I guess we don't want Skynet
at least we don't want.
So tell me about, because I'm still visualizing this just out of my own curiosity. How small are the subregions, and how small does it need to be for the problem to be computable?
So the size of the region is mainly driven by how many orders we have in this region. So you can calculate on a daily basis. We are computing roughly a million orders. The sub-region, to calculate it in exact terms, can be a few hundred deliveries. A few hundred deliveries means already, if you look to the possible solution space, well, this is n minus np divided by p faculty, is simply usually already in the space of 10 to the power of 12 different kind of deliveries, which is the number of atoms in the universe. So that's large enough to be big enough that you just want to have heuristics.
Yeah. Okay. So, sorry if this is a little bit ignorant, but I'm still trying to think the subregions, like on a map. Then, if you're talking like Amsterdam, for example, how many subregions is it?
So Amsterdam has 750,000 or 800,000 people that are living in Amsterdam. We have split it all together in 13 different regions.
13. Okay, so
yes.
that's the scale. Okay, sorry. So that makes it a lot more concrete in my mind. So I thought for the watchers and listeners, I would ask that too. This is all fascinating. Watchers and listeners, if you have questions, shoot them. I'm gonna just keep shooting mine because I have so many based on what you just said now. So now I wanted to kind of circle back to, okay, so is this also part of the kind of the question that we're asking here in terms of, well, you've built this and now how does it scale? Like, I want to dig into the magic formula of, of growing in all these directions at once. On the one hand, I see that you kind of have more and more subregions, more and more orders, right? But when we were talking about this, you seemed to kind of highlight a few different levels on which, Picnic is scaling and you're managing to make it happen all at once. I can bet a lot of the watchers and listeners, people listening to the podcast later, maybe, hi, good to have you here. If you're listening to the podcast, are thinking, okay, how do I achieve that? So can you talk a little bit more about that? Which directions is that, and how you're managing to kind of balance it out, have it all in a sense?
Having it all is never always possible. But let me maybe explain a bit the kind of the 3 dimensions that we are growing roughly at the same time. First is there's geographic expansion. So that means a new city, a new area, a new country, etc. And that is pretty classical business growth, which requires also a bit of work on the tech side, but that is limited. It has a very interesting challenge that I will mention a little bit later. The second dimension is automating more and more of those kind of processes. And what is interesting here is that how do we identify what to scale, what should be automated and what not. And the interesting aspect is we are not looking into what is maybe most expensive or maybe most labor intensive, but we are looking into which kind of functions in the business or in the company can we no longer operate if we are 10 times, 100 times, or 1,000 times bigger. This is a pure kind of a scale question. Is if we are 100 times bigger than now, which will happen not too far from now, can we still do this 100 times more than what we do now? So if something, for instance, in a linear wheel scales, everything what we cannot operate, if you're 100 times bigger, we automate. Everything what we can do, so which is superlinear scaling, we will certainly not yet automate. That comes maybe at a later stage. And the third one is, the third aspect is, how can we expand our business operating model with the same kind of infrastructure to maybe offer more services? So a very interesting example is we do forward logistics, meaning we deliver products to customers from a warehouse or from a food producer. If you then look into what is your asset utilization, so for instance, the cars that you have on the street, you use them only 50%. You go full to a customer, you go empty back. So only half the time, not really good. So if you would use only half of your development time, then you would say, well, you develop 20 hours per week, and the other 20s you're playing some games. Not good enough. So what we are looking into is then how can we increase the utilization from 50% to 70, 80%. So that was the starting point where we said we can maybe also take stuff back from a customer to a retailer. So one example is, if you buy fashion, then many people are actually buying fashion the following way. You're actually buying 5 pairs of jeans, you pick the one that you like, and you send 4 back. Everybody is doing this.
I just did that last week. That's true.
Exactly. So that means in such a world, there's a lot of return from customers to merchants. So normally a customer would say, well, I need to bring this to a postal service and need to send it back, which is annoying for the post, which is annoying for the customer, annoying for the merchant, because it's expensive. So we solve basically for all 3 dimensions the problem by taking it back with our vehicles to the merchant.
So I could order my groceries and also kind of hand off my unwanted jeans at the same time.
That is exactly what you can do with Picnic. That is exactly what you can do here.
Seriously. Okay. So that's how you're kind of managing to utilize, and that's kind of a new business line for you, but also one that perfectly fits into what's already happening. These cars are already driving around.
Yes. So that's one of the many opportunities. I think an interesting challenge is always, how do you pick the right challenge to tackle? It's never easy. It's never easy. Sometimes I'm getting the question as, this is pretty annoying to say so often no, because we have basically 10 times more ideas that we can realize. So if you look to a roadmap, then there's a very long roadmap, and I need to tell everybody, well, actually we do the first few items, but all the 90% that is in the second half, as or the second 90%, the bottom line is cannot be done, which is actually something you should be happy of. So first of all, it says that your business is very creative. So we have a lot of opportunities, a lot of ideas that you can do. It's even much worse if you have a roadmap where everybody is asking you to do exactly what you can do with your capacity, with your development power. Then you have a very non-creative business or product counterpart, because in essence, you want that you need to make a selection. So therefore, I think it's nice to do this kind of selection. On the other hand, you need to find a very good kind of technology or product model to assess what is the most important thing to do now, while you build usually this kind of mix out of what do you need to do bug fixing wise, so killing the fires that are burning, what are important critical features that you need on the short term, and what are strategic capabilities in the future that you build. And that is something what obviously on a feature on a product set, let's say product dimension you build, but also on the technology side. So for instance, when we made the adaptation to Kubernetes and to Terraform and to Helm and to Docker, etc., which we didn't have in the beginning, but which we did in 2016, 17, 18, we looked into not only what can it bring us on the short term immediately, but what can it bring us now in 2022, when we are scaling extremely fast and have to manage a pretty large set of microservices that are deployed across all kind of AWS availability zones.
Okay, so a few follow-up questions about that, but one that kind of immediately comes to mind is, we're talking about how Picnic is scaling fast and in many directions. Can you give us like an idea of the scale of this, actually, the scale of the scaling, like the pace, what are we talking about in terms of, because that is obviously a huge challenge. So can you like give us an idea of the magnitude here?
Yes, maybe 2 numbers that I can share with you. So the first one is week over week we are growing somewhere between 3 to 5%, which if you do this every week compounds to a very
week by week, you said
week by week, which is a very significant number that you then get on a yearly basis. But even if you look to the absolute size, we had last year an annual sales of $1 billion, so that has grown already to a pretty nice size, and we just continue to grow like that for a couple of more years, and then we will see where we end.
Wow. Okay, great. So thank you, because that really lets me know that this is a huge operation, obviously. So I'm not sure if I got like a satisfying enough question to this whole. I'm making notes here, which you don't usually do, but I'm trying to latch on to so many different things here. Is like you mentioned that the challenge is how to pick the right challenge, right? So when you are faced with a decision like this, obviously, being CTO, you're faced with some of the biggest decisions there are. How do you usually weigh them? Are there any kind of questions that you ask yourself? Because I'm seeing, fixing fires versus the short term versus the long term. But when it is the time that you actually decide, how do you calculate that?
I think there's no real kind of a magic around it. obviously this kind of killing fires and more short-term topics you do much more often. So that is something what you review on a weekly basis. The more strategic, bigger topics you work on more on a quarterly basis. What we do as a planning model is that we align all kind of different kind of product roadmaps and business roadmaps on a quarterly basis. So every 3 months, we take a step back. We are reviewing what have we done over the last 3 months, where are we standing now, and what should we do for the next 3 months, and are we still on track on what we want to achieve in the next few years. And then it's all about also adjusting a bit the red dot on the horizon, because some new opportunities are rising where we also, let's say, update our strategic direction. Sometimes also new technologies are popping up. So an example is that there's a lot of stuff happening around drones, a lot of VR and AR, a lot of around autonomous driving that is maybe not immediately applicable all to us yet, but we know that these are maturing technologies that will become very relevant for us in the next 3 to 5 years. So therefore, running first kind of prototypes, first hackathons, first sessions where you experiment a bit with those technologies are something that is certainly on my agenda, and it is the most important thing to do here.
Right. Yeah, because you need to be kind of stay, 2 steps, 3 steps, 10 steps ahead of whatever is coming, so that you keep this kind of market advantage. I get that. I also wanted to follow up a little bit on the automation front. Again, just out of my own curiosity, can you point out something that you saw? And first of all, well, you made this decision to automate it because you decided, it's no longer going to be possible to do it manually when you're 10 times or 100 times bigger. Does anything come to mind as an example of something you automated and it made a big impact?
Yeah, no, there are probably 2 good examples. So one example is more around our customer service default responses. So let me give you an example. So we are asking customers for feedback on our products. For instance, also if they have ideas, what else would you like to buy at picnic? Then you send an email. A very simple automation that we did is we simply sent in a response that we received your feedback on a specific item. Already so many customers have asked for this item. We will cycle back in a couple of weeks' time when we know more if we can list this item or not. That has helped us quite a bit in, let's say, the customer service effort. Another very interesting automation project that we launched last Friday, together, by the way, with the King of Netherlands. So he was here at the official opening ceremony, is our automated fulfillment center. So what we have been doing here for the last 2 years is we have built a fulfillment center where all the kind of order operation is done in a robotized fulfillment way. So, and what a robotized fulfillment means is that you as an order picker are no longer manually going to a product, but the product comes in a robotic way to you over conveyor belt and etc. And the only thing what you need to do is then basically putting it together in the consumer order, but that is reducing by 95% the walking time that you have to do in a warehouse. So these are very interesting automation projects that we have done. What is interesting with robotic automation is all of us love cloud and deploying all our stuff in cloud, and basically most businesses are cloud native these days, etc., etc. If you really do a robotic control at scale, you need to have some software and some infrastructure on-prem. For the simple reason that latency is simply, there's such tough latency requirements, sub 1 millisecond, that you can't fulfill with a typical general purpose cloud provider. Doesn't matter which one it is, but with a general purpose cloud provider, you always have latency somewhere 10, 15, 20 milliseconds in a peak, which is not good enough for the robotic control on robotic motors, etc., that you need at a highly robotized warehouse.
Okay, so what kind of problems does it actually cause? Because I'm imagining all sorts of scenarios here. I'm imagining kind of you used cloud and then the robots were behaving in a strange way, maybe, or you just, imagine this might be a problem. How does this actually manifest in real life? Is it that they're navigating incorrectly, or how does it work?
No, well, we have already built it initially on-prem because we knew that it would not otherwise work. But if we would have done in the cloud, then the following thing is happening. You have maybe a product tote. So this is a kind of a big bag where you have maybe 20 bananas in. And those kind of bananas need to go from a storage location to a pick location. So and that is maybe a way it goes over 500 meters through a different kind of conveyor belts and other kind of robotic movements that need to happen there. In order to do this, you need to go a couple of turns. In order to do the turn, you need a motor needs to put something from left to right in order to go, let's say, to the right turn or the left turn. That is something that needs to happen on a sub-millisecond precise way. If this is not happening, your banana will just end up somewhere completely different.
Okay. You need on-prem to get your bananas where they need to go.
Move the bananas in the right way. So that is a very simple, let's say, scenario that required for, and there's software for this. This is called a transport. This is a transport service. There's with programmable with PLCs, so programmable logical controllers, etc. Very low-level stuff, including assembler and coding that is necessary to do this kind of robotic control.
Sounds like a very exciting engineering problem, actually.
It certainly is something. It's a very exciting problem that reminds you very much on your microcontroller classes that some of us may have had at a university, which you never had, which you completely, most of us forgot about because we're building now software in the cloud, etc. So we have a lot of abstraction from the physical hardware, but you are now much closer to the hardware.
Right. Okay. Because it's all happening in the physical world. Well, I'm really glad I asked that follow-up question, and now I can really see kind of the value of having this. I mean, the non-feasibility, let's say, of cloud here, because it's like you said, it's a trend. Everybody wants to go to the cloud, but not everything is possible there. So I wanted to follow up on. I'm trying to still kind of fulfill the kind of the promise that we had for this session, because I can see all the different ways that Picnic is kind of growing now, grabbing more territory, automating, and doing these new business lines. And honestly, I think it's genius with the get your groceries, return your jeans type of business. And I'm really waiting for this to come to Poland then. But kind of to fulfill the promise, then what do you think is the key to actually doing these things all at once, in parallel? Because I feel like if we're going to kind of explain the magic formula, so to speak, is there anything in particular that you think you're doing kind of differently or better that's allowing all of this to happen at once?
I think it's hard for me to speak about the difference to other businesses because we have not started this so well that we can really say this is the magic formula and that's the reason why it doesn't work with other businesses. Sure. But maybe there's one magic that we have applied that is most likely contributing to it. For everything what we do, we are not so much benchmarking ourselves to market solutions, or we are not comparing ourselves to competitors, but we are taking a kind of a bottom-up white paper approach, where we reason from first principles, how can the best possible solution look like, and what is a path to build the best possible solution from where we are now, which is maybe a very manual and laborsome implementation, up to the best possible, most automated, most robotized, most AI-ish type of a solution in the future. And this is a perspective that many businesses are not taking in this way. But if you do this, then you can actually operate and develop in multiple dimensions at the same time. So you can do more of what you do now, which is this kind of business development. You can do actually more type of services. So this is the business expansion. And you can do it with less effort, which is the automation dimension.
Okay. Wow, that is such a good question to have in the back of your mind. Again, I made a note, and I think you're actually right on the money here. A lot of businesses are looking at what the competition is doing. How do we kind of innovate on top of what they already implemented? But maybe the perfect solution is actually a whole different approach altogether. And only by asking yourself, what is the best possible solution, do you actually start arriving at that solution?
Maybe just to add one interesting thought here. The reason why many businesses or ventures are shying a bit away from this approach is because this is not rocket science. So what I'm saying here is obviously something that others have also figured out. But you need to be willing to move a little bit slower in the beginning, because you need to figure out, if you start from scratch on a white sheet of paper, everything, you need to be willing to move a bit slower in the beginning, while you will be move much faster later. So everybody sees the red dot on the horizon that you move faster later. Allowing in the beginning to hustle your way along and to move slower is something that requires a lot of stamina and a big commitment from you as a team, but also from your investors and from many others, to allow you to actually do this kind of bottom-up approach. And not many are actually able or willing to do so.
Right, because I imagine this competition analysis might take a little bit shorter than just sitting down, whiteboard. Okay, how do we kind of think about it just from the very beginning, from scratch, how to solve that?
A competition analysis makes sure that you basically copy what others have done well, and you do and you try to improve a bit on the things where you feel you can be a bit better than others. But that typically misses out the big opportunity to really from scratch and from bottom up do something fundamentally better.
It allows you to kind of get better at the game that's currently being played, but maybe you can reinvent the game, play a whole completely different game.
Why not playing another game?
Yeah. Okay, I get that completely. Okay, so let me look at the time. First of all, I wanted to ask you, just on a kind of technical level, do we need to finish right on the hour as soon as 4 p.m. rolls around, or do we have a few extra minutes? Because I don't know about kind of the last bits, the announcements. I want to give you time for that, but I also have additional questions. So what's the answer there? Do we need to finish right in time?
I would prefer to finish pretty much on time.
Pretty much on time. Okay, so one question, two tops, and then I'll let you talk a lot about your announcements and just 2 words about STX Next, and we'll be finishing. So watchers and listeners, if you have questions, final call. Meanwhile, I get the feeling that we didn't go deep enough into the subject of architecture. Somehow, it feels like in the back of this all boils down to architecture and its kind of impact on all of this. And you even flagged at some point, we're going to get deeper into this a little bit later. So let us get deeper into this. Do you think like architecture is I don't want to phrase the question in a way that doesn't allow you to provide the right answer. So maybe let's phrase it like this. What is it about architecture that kind of makes you highlight it so much? Why is it so important for you, and why should it be important for tech leaders?
I think architecture is, first of all, I think architecture is a very overloaded term. And if you ask 5 engineers, you get 7 perspectives on architecture.
Yeah.
While I think there's a shared common understanding that you have a couple of boxes and you need to write a bit what are your classes and the properties, etc. However, what becomes very important is that architecture is probably as a tech leader, your software architecture defines the limitations or the opportunities towards the future. And what I mean by this is, if you are thinking about implementing a new feature, extending your current implementation or make it more scalable, etc., is driven by the core architecture, how you have organized everything what you have built. So there are simple examples. For instance, code duplication. Obviously, nobody wants to literally duplicate code, and that is something what all static code analysis tools can identify. The much worse duplication that many software systems have is duplicating on a partial functionality. So you have 2 implementation that are differing only by 10 or 20%, which is technically not really duplications, but they have 80 or 90% commonality. So what you could do, obviously, is that you factor out the commonalities and you have only this kind of 10 or 20% that are different on both, taking as a kind of a class extension or however you model this in your architecture. Thinking about this in a very structured way allows you to make the kind of the third implementation that is another, let's say, 20% different in a much easier way, because the next time you don't have to make again this 100% implementation, but only the 20% that is different. And that is probably a very simple example here. But if you multiply this, because that is something that is exponentially growing as your tech stack is growing, it makes a huge difference in how fast you can move going forward. The main reason why, for instance, building something from scratch goes faster than building something on top on the existing system is that if you have an existing code base, then most of the development work that you do is changing existing implementation. Most of us, if you work in a company that is older than 5 years, I promise you that you will spend at least half of your time changing existing code, not building new code, except maybe just in very exceptional cases. So therefore, thinking from an architectural perspective, making architecture a first-class citizen, and let your technical leaders not talk about implementation. Leave implementation to your developers, even technology choices sometimes, but talk about APIs, make API-driven discussions, and make architecture a first-class citizen, also between tech and product and business. Then you will certainly end up in a much more scalable business environment.
That makes a lot of sense to me, because these developers, again, you're saying past the 5-year point, more or less, they're going to spend so much time navigating what can be kind of the maze of existing code. The more you can optimize that maze and make everything more accessible, you're optimizing all future work by focusing on this architecture part.
Yes, exactly.
Okay.
What should I say?
I just want to make sure that I'm getting things right here.
You're absolutely spot on. Well said.
Thank you. Thank you. Yeah, just wanted to make sure, because personally not a developer, but I'm learning so much from our Tech Leaders Hub guests. Okay, final question before I ask you about announcements, where to follow you, etc. And again, this is a traditional question almost at this point, but what I like to ask is, just to be sure to cover myself, is there anything else that you wanted to kind of mention within this session? You were kind of excited to talk about it that I somehow haven't asked about, that you would also like to put out there as kind of advice for tech leaders or the audience at large?
I think as tech leaders, we are all very strong on understanding both technologies and development processes. I think that's something what we are trained to. That is something what we are good. Many of us are getting more and more involved and dragged into business, but I think what we all need to learn better is need to find a common language between tech and business in a form of architecture, but also in form of not thinking in features, but thinking in, let's say, outcomes and KPIs. So what I'm encouraging all my tech leaders and all my product leaders is think in, so define for your tech stack and for your products the 3 most important metrics. And the only thing when we're talking about a roadmap, just make an assessment or a judgment on how those kind of 3 KPIs will improve along with this kind of new feature implementation. No qualitative judgment, but at scale, make a metric or KPI-based judgment on maybe a more technical implementation or maybe a product feature implementation. How does it improve the KPIs? If you set this up, it's very, very hard. But if you set this up, you have an organization that can easily scale to Google size of 10,000 plus developers.
Amazing. So to shed just a little bit more light on this, when you're thinking about building new features, etc., can you give at least 1-2 examples of KPIs that you're looking at?
Yes. So for instance, if you build such the tech stack for an e-food company consists, for instance, of consumer app. So there's an app where customers can place orders. We have only 3 KPIs. So the KPI is a conversion, meaning, and that has two aspects, but mainly conversion, meaning you register, how likely is it that you actually place an order. The second one is the average basket size, and then retention, how long does it take that you're coming back to the shop. Every feature is measured against those kind of 3 KPIs.
No, and that's company-wide?
That is, the company is tech, so yes. That is, but this is for this specific feature. There's the same also for and purchase order management system. So this is the system that is buying the products, the system for fulfillment. There's another set of 3 KPIs. If you think about 3 KPIs for your product, you're certainly already quite a step further. The same, and this is obviously a business or product metric, you can do the same also for tech metrics. So for instance, for our hiring process, we have 3 tech metrics. So what is the time until an engineer makes a first pull request or gets the first pull request merged? What is the time till the 10th? So first pull request is he at least a little bit onboarded? 10th PR means that he is fully onboarded. He can run. And then the third metric is for pull requests, how long in average are pull requests open from this engineer? Or the other way around is how many people are actually motivated and engaged in the pull request of an engineer. So good onboarding means you have quickly done your first. It doesn't take you too long that you have done your 10th PR, and you find a lot of people that want to help you with your pull request on an ongoing basis.
And that's how you know you're doing a good job with new hires. It's amazing. And Daniel, honestly, I'm a little bit disappointed that we're almost at the 1 hour mark here, and we don't have any extra time. So let's just get the kind of everything else out of the way. First of all, thank you so much for sharing your knowledge. I feel like I just got a master class on how to kind of run and scale an e-commerce as a CTO. Great stuff all around. Value per minute was off the charts. So thank you so much for sharing. And I wanted to ask you, is there anything? I wanted to ask you if there's anything you wanted to announce in terms of, I don't know, hiring. Where do you want people to follow you, follow Picnic? Now is the time to kind of self-promote if you want.
There's nothing that I need to promote on myself, but what I want to actually share with you guys is if you are interested in what you have heard so far, then have a look to join.picnic.app or www.picnic.app, where you can find everything about Picnic. We're looking for software engineers, data scientists, machine learning engineers, deep learning, whatever. If you do something with tech, you will certainly find something interesting at Picnic. Hope to talk to you very soon. And I think we all together in tech are building the future. So you need to be very much aware that we are shaping the society, how it will look like in the future. So be also aware that you do this in a responsible way.
All right. Yeah, that's awesome. And I think you made an excellent case for joining Picnic. As for ourselves and who brought you this live session, we're SDX Next, Europe's largest Python software development company. If your product is based on Python or JavaScript and you need developers, designers, machine learning engineers, DevOps, or more, and support with that, we can help you. We're actually visiting the Netherlands next week. Some tech consultants from our side are coming. So if anybody here based in the Netherlands wants to meet with us and get kind of consulting on how to grow faster, grow better, build better software, we're there, in the Netherlands and globally. SDXnext.com. For more Tech Leaders Hub, to follow us and get informed about upcoming session, techleadershub.com. Follow SDX Next on LinkedIn primarily, and that's where we are the most active and where you will certainly get more exciting Tech Leaders Hub sessions like this one. All right, 3:58. I did promise we're not going to go overtime. So Daniel, thank you again so much for finding the time to be a guest on our session. I honestly love this. And do you do these often, I wonder?
No, not really.
You should. You really should. You're a natural at this, and I've run a few of these, so I should know. So thank you again for being our guest, and everybody else, watchers and listeners, you have a great rest of the day.
Thanks, guys. Have a nice day.
Yeah. Thanks, everyone. Okay.